Great. Thanks, everyone. This is Mark Petrucci with Applied Software, the Construction Technology Group. All right, so the first thing I'm going to discuss is data acquisition, scan to BIM. Some of you may be familiar with scanning, others may not. There have been some new changes with scanning recently that I wanted to show you. So we're going to talk about laser scanning being an ideal solution for BIM. With 3D scanning, we're able to scan large areas quickly and accurately. When I first got out of college, I did a lot of as-built measuring, and there was 2 of us, and we always missed something during our measuring process. With 3D scanners, we're basically shooting millions of points. We're capturing millions of points in literally just minutes. And with those points, then, we can view them on the screen and basically see a 3D model almost instantly. A nice feature with the new scanners is the high-resolution imagery that is attached to our 3D scans. If you've looked at 3D scans in the past, they were hard to make out because all the points looked exactly the same. With the imagery that's added with the points, it actually looks like the area that's been scanned. I'm going to quickly just show you 2 scanners, one the Topcon GLS 2000 and the Dot Product DPI 7 scanner, and just give you a little example how they're on 2 different ends of the spectrum, but can both be used and very powerful as far as collecting data. The Topcon unit you see here will shoot point cloud or measure out to over 1,100 feet, and it will easily collect points in full dome in about 3 minutes with images. There's 2 cameras on this unit, a telephoto lens and a wide-angle lens, so we can capture very high-resolution images if need be. But what's really different about this unit compared to some of the other units that are out there is that it will register scans automatically. Now what that means is many times we have to take this scanner, we set it up on a tripod, and we'll move it to different locations in a particular area, and then after we'll tie those different scans together or we'll register them together. This unit will recognize it during the scanning process and register automatically for us. And another big important feature of this is that it integrates with APL control points. And I'll show you Autodesk point layout a little bit later, but as long as we have control points at the job site in our model, we can take this point cloud and bring it into our model quickly and compare it to our design model. Now what I wanted to show you here is just a quick little video. I'm going to turn off the volume here. It's a very short video. This is a picture of the room. There's the scanner. And for those of you who haven't seen point clouds, you are looking at a point cloud. And notice that as we move around, the imagery kind of fades a little bit and we're looking at the points. But as we stop, then all those images that have been recorded now are visible. So it looks like we're in a true 3-dimensional model when really we're just floating around in our point cloud. We do work with other partners that will recognize these points that represent a pipe and replace those points with an actual pipe. So there are ways then to convert this point cloud into a BIM file to use back at the office. On the opposite end of the spectrum is this Dot Product DPI 7 scanner. It's a small handheld unit, and what's great about this unit is it's great in tight spaces. One of the things with the larger scanners is that you have to move them constantly. They set up in one location, but they may not see the entire room because objects may be in the way. Well, with this unit, you are literally walking around the space, and you can walk around objects that are hiding specific locations in the room. It also has real-time markerless camera tracking. You may have seen scanners on job sites where they place markers up on walls or columns. They use that on purpose to tie those or register the scans later on. With this unit, it'll register the scans automatically. And the range on this unit is anywhere from 2 feet to about 13 feet. That may not sound like it's far, but actually for what this is designed for, it's the perfect solution. And I'll just show you a quick video of what it looks like running this scanner. Here we're holding the scanner. You got a nice big screen. You can see it. It looks like you're shooting video. But what we're going to do is we're going to get this set. We'll hit the record button. The screen turns green. And now literally you're just walking along and you are scanning everything that you see on the screen. And so basically you're just going to move this up and down and around until you grab all your points. If later you find out that you missed a spot as you're reviewing it here, you can go right back to it and it'll register the scan where you left off. All right, we'll turn it back over to Lyle, and he will go over the MEP portion.
All right, thank you for that. My name is Lyle Yonda. I'm a technical advisor at Inceptia. What I'd like to show today, so what Mark just showed us, so once I have the point cloud and the model's been generated in Revit, now that I have it in Revit, I want to take this and send it over to a fabrication STMEP or CAD MEP, so that way I can generate my fabrication intent model. To do so, for this example, I'm going to use Revit to export out my system and send it directly to STMEP to get my estimate. So let's go ahead and select my medium pressure duct. Now on my add-ins tab, I have store design line elements and store graphic elements. Store design line elements is used where Revit elements can be mapped to corresponding items in CAD MEP, such as ducts, pipes, straits, and fittings. Graphical elements is used where where no mappings can be made between Revit elements and CAD MEP items, such as air handling units, pumps, things like that. So I'm going to select store design line elements and save this out as my RIF file. So once I have that done, I'll just go ahead and I'm going to bring that directly into STMEP. One thing I'll note here with fabrication products having a unified database, I can bring this directly into STMEP, and that will allow me to send it straight to CAD MEP to finish out the detailing and CAM duct. So it's really what I want to show in this process. Go ahead and import that RIF file. And you'll see here, I've already gone ahead and it remembers, since I've done this already, I have my system type and my system name. Here's the information brought over from Revit. I'll simply select the service that I already have defined in CAD MEP in my database. And the service, I have my pressure class assigned to it, so when I convert this over, it will give me my standard straights and fittings based off of my shop standards. So I'll go ahead and select OK. And there you go. That was that quick, converting the Revit model. If I zoom in here and I look, you'll see my straights are based off my pressure class. You also notice that there's some missing gaps. So while this is a good conversion, there's still going to be some things that need to be fixed. So like I said, if I look here, here's my standard straight, following my pressure class, giving me the correct connectors and seams. We'll worry about fixing this stuff once I bring it into CAD MEP. Run my estimating summary. Here it will give me a material cost, fabrication cost, and install cost, all set up based off of your shop standards, and give me a total. If you're using plumbing or pipe, you can also use Harrison or a similar supplier to bring in your pricing. You can also run reports. So here's an ancillary list, as well as export this data out to Excel. So once I've won the bid, I'm ready to send this over to CAD MEP and let my detailers finish out and fix some of the things. So I'm going to go ahead and save this. And open up CAD. I'm going to open up that same exact design in EST. And there you go. So now that I have it into CAD MEP, I'll go ahead and make the changes that I need to, so that way I can get it ready for coordination. So I'll take a look here. I've gone ahead and made some of the changes that I need to and fixed some of the changes as well. I wanted to note when I bring it over into fabrication, with design line, it will fill in my hangers automatically. So that's one thing that was added from the Revit file to CAD MEP and STMEP are my hangers. So now that this is ready to go to Navisworks, I'll send it over to Mark.
All right, thanks, Lyle. All right, so now I'm going to talk about coordination because we have that design file now that Lyle has done. We want to make sure that it's coordinated with the rest of our project. So we have a couple different ways of doing this. Autodesk Navisworks has been around for years, and traditionally we've used this primarily for clash detection. Navisworks does a whole lot more than clash detection, but this is just about what everybody uses Navisworks for. Recently, Autodesk BIM 360 Glue. It is another product by Autodesk, and it's a cloud service that we can do clash detection in the cloud. So both units allow us to do clash detection. We get reports and we can find out where the clashes are. But there are some advantages that Glue has that Navisworks does not have. And there's also some advantages with Navis. Let's just look at the workflow when we use Navis and then the workflow when we use BIM 360 Glue for coordination. So Navisworks Manage. Typical workflow. Typically you have your architect, your structural engineer, MEP engineer. They're all working in their own little silo, creating their models, and then they will send it to a BIM engineer. Typically the BIM manager. The BIM manager will collect the files. Now the way the files are sent traditionally has been like FTP, and that could take many hours. Then the BIM manager has to download those files, has to put them all together, bring them inside of Navisworks, and then start generating clashes. When clashes are complete, then clash reports are sent to the architect, another set of clash reports are sent to the MEP engineer, and each discipline is working independently trying to resolve their clashes. Once they resolve their own clashes, the architect will get the files back to the BIM manager, maybe in a couple days. The MEP engineers, they're a little bit better at this, and they'll get their files back to the BIM manager maybe on Wednesday. On Thursday, the BIM manager then collects all the files and starts to doing clashing again. By Friday they may have resolved 50 clashes, but because the architects and engineers have been working in their own files, there may be 40 new clashes that have been created because they didn't know the changes that were taking place with the other disciplines. Now this has been the traditional workflow with Navisworks Manage. It can always be improved. It's still a very good workflow, but let's talk about how BIM 360 Glue will be able to do that. And actually I have a video very quickly which I forgot about. This is going to show Navisworks and how quickly we can do a clash. In this particular file I have structural, MEP, and I have an architectural model that I'll bring in. I receive these files from the architect using AutoCAD or Revit, and I'll just quickly generate a clash report. So I want to clash and see if I have any ducts that are interfering with any of my structure. So I'll go ahead and select from my MEP model, I'll go ahead and select just my ducts. Now this is the BIM manager doing this, and quickly, instantly, we get a report. And so here's clash number 2, and when I select it, it takes me right to where the clash is. And if I keep clicking on a different one, it takes me to a different clash. The rest of the model is grayed out, so it's very easy to identify. What we typically do is generate a report, a paper report or an electronic report that gets sent off to the architect and engineer. But that paper report is obsolete. As soon as one person makes a change, it's obsolete. So with BIM 360 Glue, what we do is on Monday, the architect, the BIM manager, the structural engineer, MEP engineer, they, instead of sending their files to the BIM manager, they send it directly up to the cloud, to the BIM 360 cloud. And so now at any time during the week, the structural engineer, the MEP engineer, they can compare their models. The MEP can quickly do a clash detection anytime, and they don't have to wait for the BIM manager to do it. They don't have to wait for him to collect the files and then send the reports out. It's advised that as you're working on a project that you update the model in the cloud at least once a day, if not 2 or 3 times a day. It's very easy to do with just one click of the mouse. So really, we can get a coordinated model by Thursday instead of Friday. We finish a little sooner, and actually we'll have fewer clashes because we're always comparing our updated model with whatever's in the cloud, and as long as everybody's updating regularly, we'll be able to resolve clashes much quicker. Some key advantages of BIM 360 Glue coordination over Navisworks. First of all, the model is up in the cloud, and so there's always the latest version up there. But a nice key feature is that we can run BIM 360 Glue on the iPad. So I can review the model on the iPad as well as in the office. At the same time, I can do markups in both locations. And what's beautiful about doing the markups using BIM 360 Glue is that there is a view that gets saved wherever the markup is, and you send that off to the person who needs to resolve that particular issue. And as they resolve it, they'll get a link, they'll see it, they know what corrections they need to make, they can quickly update their model and then repost a new model up to the cloud or glue a new model up to the cloud. The round-trip workflow, there's a feature inside of AutoCAD, Revit, Navisworks called Pinpoint. When there's a clash up in the cloud, I can pull that down into my model and pinpoint where it is, so it'll highlight a specific object that's clashing. So I don't have to go searching for it. Pinpoint will take me directly to where that clash is, or the object that is clashing. You'll see right up here, this is Revit. Here's Glue, and I would just click on it to glue my model up to the cloud, and here's my pinpoint. After I do my clashing, I would do pinpoint. I'm going to go ahead and just show you a quick video. So one click, I click Glue. The first time it's going to ask me where to post it. I'm going to pause this right now, and I'm going to post it to a specific project that the BIM manager has set up. So once it's been set up, now anybody who's been invited to this project can glue their model. I could also review markups, clashes, any new views that have been created. I could review this list of files been recently modified. As I access this project, I can see all the activity that's happened with my model. I am now opening up the Glue model from my desk, but same workflow from the iPad. But on the desktop, I already have a clash report created. So I'm going to rerun it. And as I run this, I'll notice that I have a list of clashes. I have 79 clashes. Just like in Navisworks, if I select the clash, it takes me directly to it. It highlights the two objects. There's actually another screen I could turn on that gives me more information about each of these objects, but I can see visually where they are clashing. And from here, I could email that clash to the necessary people to get that resolved. So now that the purpose here now is to make sure that we have a coordinated model. So by taking all the reports, the clashes that we have found, and then resolving those clashes and updating our model to resolve those clashes, now we're ready for fabrication.
Okay, so now that, like Mark said, this model is ready to be fabricated, for this exercise, I'll send this to CamDuct since I've got sheet metal items in here, as well as if it was pipe or plumbing, I can go ahead and create my spool sheets in here, or create my linear nest sheets for my pipe cut list. So to export this out, I'll just cam it out. I've already done this to save some time, but what I want to make note here is after I've cammed it out, if I'll take a look at the status on my items, it's issued for manufacturer. We'll take a look at this in CamDuct after I nest it and create the NC file. So once I've exported it out, I can open up CamDuct, open my job, take a look. Here are just those items that I exported out, just my rectangular pieces. So once I have it in CamDuct, and CamDuct's been set up for your specific equipment out at the shop, I can set up a process to easily create my NC files. With this process, I can also have it automatically print reports and labels. So let's go ahead and select my process. And what you're seeing here, it went ahead and created the NC files that I need for the table. It was that quick. If I go out to the shop, I can punch in this NC file. I can also preview it in CamDuct to make sure that it's going to do what I want it to do at the table before I burn this. It's just kind of a checkpoint to make sure that it looks correct before I burn this. Just kind of speed that up. As well as, like I was saying, some of my labels and reports. I'll take a look here, going back to that status, I can print out my item labels and put a QR code or barcode, so that way I can use Tracker to scan each item, and it will change my status depending on wherever this is at in the workflow. So I've gone from EST to CAD, from CAD to CAM, out to the shop, onto the truck, installed, and so forth. So I can track that whole process by using Tracker. So here's my item labels. Here's a weight summary sheet giving me a total of metal used and my ancillary list. So we'll go ahead, once that's done, then I'll send this back over to Mark and we can take this model out into the field.
All right, great. So now we've got our product. We want to go install that in the field. So we need a quick and accurate way to locate in the field. So this is where Autodesk Point Layout and Robotic Total Stations come in. So how do we do this? It's really very simple to get our MEP CAD BIM data to the field. And I put here it's as easy as 1, 2, 3, 4. First we need some equipment, Robotic Total Stations. Next we need Autodesk Point Layout. It runs inside of Revit, AutoCAD, Navisworks. We identify the key users, typically our BIM team and our field team. It's important that we get them both working together so that on on step number 4, in 3 to 4 days of training, you can be fully integrated and working together to get the CAD data, the BIM data, out to the field accurately. So how have we always done it in the past? Traditionally, we've always done it with a tape measure, printed hand or CAD drawings, field notebooks. You know, who knows if we have the latest drawings? And our tape measure, field notebooks, mistakes happen. We don't mean for that to happen, but sometimes we'll take a measurement that should be 16 feet 9 inches, and we measure 19 feet 6, and we write it down incorrectly. Well, we need a way to reduce those mistakes, and so that's where the Robotic Total Station comes in. This particular total station is the Topcon LN100. It's completely robotic. And when I say robotic, that means one person can operate this. In the early days when I was working in the field, there was always 2 or 3 of us. I was the rod guy standing there with one guy looking and telling me which way to go. Well, with the Robotic Total Station, I set this up. I have a handheld tablet PC, and I look on the PC and it tells me where to go to locate my hangers, for example. What's really nice about this unit, it is easy to set up. It's self-leveling. So basically, I press this green button. I just wait about 45 seconds. It'll spin around, make sure it's level, and I'm good to go. It'll shoot up to 330 feet, so about 600 feet total diameter, and I'm accurate to within 1/8 of an inch. I can shoot to a prism, or I should say I shoot to a prism to measure. There are some units out there that will shoot prismless, but depending on the angle in which they hit, it's not as accurate as shooting with a prism. So here's an example. These are the basic components that you need. The Robotic Total Station can be mounted on a column. On the MEP side, if you get into the project when you have metal deck, get a column clamp this to a column, and then you can locate where to place your hangers on the metal deck. You can punch through, put in your bangets, and then proceed on. The data collector, which runs Windows 7, and just recently on the iPad, you will see a floor plan of the space you are in. The total station knows where it is, it knows where you are, and it will direct you where to go. Literally, this person you see in the drawing does not need to pull out a tape measure. He could just simply look at his screen to move around. And the prism is what we're measuring to. So there's the equipment. Well, to use the equipment, I need to get some points. So what are points? Here's some examples of what points may look like. On one side I have Revit, on another side I have AutoCAD. I have some hangers, and at the top of the hangers gets placed an object. That object will have a X and a Y coordinate as well as an elevation coordinate if needed. It's not always required, but it's always there. Those points then I could use with my total station. Other features I can do is I can locate walls, or a feature with Autodesk Point Layout, I could do a slab analysis to see how flat a floor is. So there's a lot that we can do with APL than just locating our hangers, but it is very important that we use that to do it accurately. The 3 major workflows for APL is, one is layout. That's where we put the points in our project and then we transfer them to the field, and we can locate those points accurately, efficiently, and we reduce errors. If I measure with the tape wrong, I don't know that till later on in the project. If I use a robotic total station to locate my points, if I'm not in the right spot, it tells me. If I'm off by a certain tolerance, it will tell me. So there's no reason for me to make a mistake out in the field with a robotic total station in APL. Tie in QA/QC. When those points are located in the field, I can collect those points and then compare them to my design model. And I could say, show me all the points that are off by 1 inch or 1/4 of an inch, whatever I want to set. So I can do quality control just to make sure that what is being laid out in the field is matching my design model. Now, for some reason, points were moved on purpose in the field. I'll see that too. And then I can update my model to match what's in the field, which leads us over to as-built. There may be objects that are not in my model, but I want to record them. And so I can record points that are out in the field, such as maybe an existing pipe that's not in my model. I could shoot those points, and when I bring them back into my BIM program, I could say connect those points with duct or pipe or a wall or whatever other object I want to put on those points. This is a video, but what I'm going to do is I'm actually going to go ahead and show this to you live. So here's an example of a Revit model. I have some hangers in here, and I have some pipe. Just to show you how quickly we can put points in here, I'll use Autodesk Point Layout. There's a pipe point routine, and I'm going to go ahead and just do all the points in my project. I'll do all the vertical, and I'll do both the top and bottom. And I can give this a description. I can use a standard description, maybe the custom I just want to put in here, just generally pipe point. And then it's going to ask me if I want to include the diameter, and I'll go ahead and click yes. All of a sudden I see these little points that appear. When I touch on this point and I take a look over here, this tells me it's point number 2249. It's a 2-inch pipe point. If I click on the next one, it recognizes it's a 3-inch pipe point. All my pipes, all my vertical pipes, and conduit, if I want to do conduit as well, I can place points on them that quick. As far as my hangers, I can select the hanger, and I'll quickly modify it. I just put 2 points on the top of my hanger. I'll push that back into my project, and I'm going to overwrite these, and immediately you're going to see little points that show up here. Those points now have a coordinate associated with them, and they're associated with the project, so I can quickly and accurately locate those points. With Autodesk Point Layout, if I want to, what I would do once I locate these points in my project, I want to give them to my field team. So I'll go ahead and export the points. And if I go to Filter, I can come down here and I could select all my duct points, or maybe my pipe points. But I'm going to select duct points. I'll click OK, and then I can export these out to a file. And maybe I'll put in here points to layout. And I'll save that to my computer. What I'm going to do is I'm going to go ahead and switch to a project where I already have some points in there. Looks very similar. But now let's say that my guys have gone out to the field, they located those points. At the end of the day, they're going to give me that point file back. I want to see how accurate they were at laying out points. So I can do, with APL, compare points. And I would go ahead and select the file that they staked out. This is what they started with in the morning. This is what they came back at the end of the day, staked in the field. I'll open that up, and immediately I can see that there's a delta. I've got some points that are off by 0.01 feet, and maybe I want to filter this and just look for points that are off by more than half a foot. And I got some points that are off by more than a foot. So I may raise the question back to my team and say, hey, why are these points, why did they move? But I'd like to see how these points look inside my model. And if I click on 3058, it takes me right to that point, and I could zoom out and see this hanger is that point. Now I put a little circle here to note those particular points, and I purposely moved them. And I can quickly see this hanger is interfering with the structural steel. Maybe the structural model wasn't up to date when I was placing that hanger. So because they moved those points and they had to move, I can say, let's go ahead and import your points to update my model to make it a true as-built now. So I'm going to select that same file, And I'm going to go ahead and just simply click OK, and it's coming back and it's telling me that I've got some points that have to move. So I'm going to go ahead and hit move, and keep an eye on these three hangers right here. You see where the circle is. So this hanger was moved in the field. That's where it should be. These two hangers were moved as well along the ductwork, but you can see where they used to be. So that's how quick I can use the information from the field to update my model. Next, we're going to talk about BIM 360 Field. BIM 360 Field runs in the cloud, runs on the iPad, and it's a great way to manage your project. It's designed for the construction professional to use. With BIM 360 Field, we have all the information we need related to the project, and then we can generate issues and tasks and checklists to help our team in the field. So it runs on the iPad. I'll go ahead and just click on a link just to show this. And I'm going to talk about these different options or modules that are inside of BIM 360 Field. The most important one is issues, followed by checklists, equipment, tasks. Tasks may not be used as much, but you can choose what to use and what not to use. So let's just take a look at each of these different modules. First thing is the library. The library is where we can store all of our CAD data, all of our PDFs, Excel files, Word documents, any sort of electronic file we want to go ahead and put in our library, and we can access it. It's a nice interface. You'll see a list here, a folder, and then you'll see a little preview of the different PDF files that might be available. Related to those PDF files, then, I'll use that when I want to create some issues later. But first, let me talk about photos. Pictures are worth 1,000 words. I'm at the job site. I notice a problem. I can immediately take a photo with BIM 360 Field. I can mark it up, and then from there I can email or create an issue with this photo. So it's a great way to communicate some sort of an issue in the field that needs to get resolved. So issues. This is the biggie right here. So I could log, assign, and track items to completion. So with issues, when you're walking around the project and you notice an issue, a problem, you can immediately address that issue. And what will happen is BIM 360 Field will ask you to fill in some information. For example, what's the location and what is the issue? If it's something having to do with MEP, it will automatically assign that issue to the MEP engineer. If it's dealing with structure, dealing with walls, it will automatically assign it to the structural engineer or to the wall subcontractor. It automatically does that for you. So you only have to fill in a few key pieces of information and a description of the issue, and from there the issue becomes open, and it needs to get tracked and resolved by the person that it was assigned to. Once they resolve it, it goes back to the person who originally generated the issue, and then they can inspect it, and if it looks like it's been completed properly, then they can close the issue. Otherwise, they can send it back with any sort of notes to resolve the issue. Checklist. There are many predefined checklists. We can also help you create additional checklists. Basically, with our checklist, we can adjust the responses, but yes, no, yes, no. All the yes responses, great. If there's a no response, that means there's an issue created automatically. And immediately, you have to fill in information. And so now you have the checklist to help you generate issues. Great for people that are new to the field and to review the checklist and to help them create issues when something doesn't match the checklist. And with the checklist process, there's a little signature so people can sign off on it, and also the person inspecting it can sign off on it as well. Another key feature, equipment. Building components can be tracked from design to handover. And so a really nice feature, you saw that there can be barcoding involved with some of the equipment that's delivered. With the BIM 360 Field, I can scan the barcode, and any information that's associated with that particular object can be synced up inside a field and also synced up with my BIM file as well. So it's a great way of keeping the model and the information coordinated. And then reporting, and the reporting is typically done at the office. There are many predefined reports for you. You can create additional ones, and the reporting can even be set up to automatically send out a report at 4 o'clock Monday morning, so that people receive a report on what issues assigned to specific people or specific companies, which issues have been open the longest, and so on. So many different reports that we can create with BIM 360 Field. From there, I'll turn it back over to Lyle.
Okay. So now that here at the final stage, now that I've brought the Revit model into the fabrication software, I've gone through the whole process, and now I've completed the job. I need to bring this back. This job requires a Revit deliverable. Instead of going back into Revit, at this time I don't have an exporting tool that I can just send it directly back into Revit, but what I can do is export this out as an IFC file, and I can bring this in directly into the model or send this out so that way they can bring that in. So to take a look at that, already done that. I've gone ahead and deleted out those items. If I link in the IFC file, here you'll see now that I've brought in my fabrication intent model through an IFC, and it gives me everything that I've made changes to, added my hangers and so forth. So this will give me my Revit deliverable, and really just allows me to do everything in fabrication without having to redesign everything into Revit. So that concludes this part of the demonstration. Jeffrey?
Okay, great. Thank you very much, Mark and Lyle. That was awesome. And you know, I know that's a fast-paced presentation. Let me see here. All right, so let's just kind of recap what we talked about. Again, that is a tremendous amount of information to absorb. And just before I go through this, I want to make sure everybody out there understands that the intent here obviously was not to get into what we call the weeds in a lot of these areas. There are a lot of important details that have to be addressed, but the goal of today's presentation was to show a complete workflow using Autodesk solutions, and also obviously hardware from Topcon, Sukia, and the DOT product. And the goal is to demonstrate how seamless this industry is becoming with respect to being able to move your digital information from design all the way through to handing over to the end to the owner or the customer. So there really is a lot of opportunity to avoid rework, for collaboration, for saving money in all kinds of ways, be it through simple productivity improvements, all the business benefits of doing prefabrication, safety issues that are involved with prefab, reduced insurance rates, just a myriad of benefits that all of this workflow really provides. Many of you know these things, but those of you that may not be using all of these technical tools, that's where we would challenge you is to look for how you can move some of these tools into your organization to further improve. So let's go through this one more time. We started, Lyle started, actually Mark started talking about some of the new ways that we're developing a basis of design. We have typically brought in PDF files and traced over them, or started with AutoCAD files and traced over them for the basis of design. Scanning is becoming much more so mainstream. I've been involved a little bit in the DOT product scanning myself. And as a designer, I will tell you that it is just, it is a paradigm shift in being inside an AutoCAD design environment and having the point cloud background behind me that I can see. It's just amazing that, we've been designing with this black void behind us all these years, and I think it will become very common for us to feel like we're actually in the space as we're doing our design. So I urge you to look into that. That it'll improve the quality of designs you can do for your customers, and your detailers, I think, will will find it very beneficial. The estimation piece, Inceptia has changed some of its programs for doing estimation, implementation, and training. Please contact me if you are one of those many folks out there that are doing really well with CAD MEP, but have a single license of STMEP and have struggled to get it in place and in use. There are huge benefits to utilizing the shared content database, and we can help with that. We talked a lot about the differences between Navisworks and Glue, and when I get through this, we're going to answer some questions. A lot of questions came in about the differences between Glue, and I'll let Mark speak to those. Obviously, the benefits of CamDuct with the nesting, saving sheet metal and manpower time, those are huge. More discussions about Navisworks and Glue. I'll point out that I was involved in working with customers and selling the Glue and Field, BIM 360 Glue and Field products early on when they first were brought to Autodesk. And a lot of the pricing models have changed, and it's much more affordable now. So if you looked at it at one time and it seemed outside your boundaries of affordability, I urge you to look at it again. There is a lot of horsepower there, and it's a lot more affordable. So please give that a second look. So then, of course, we talked about all the other integration of prefab with data and field management. We are doing more work with that, trying to actually get the capabilities of handling spools inside of BIM 360 Field and Glue, so you can access the data inside of a spool. So we are working on some of those details. And then, of course, I saw some questions come in regarding the capabilities of Autodesk Point Layout. And then, of course, Mark talked at length about the commissioning power of BIM 360 Field. So let's move on here to the question and answer session. Let me pull up my standby here. My questions that I have. All right. Let's see here. And Mark and Lyle, if you can unmute yourselves, I'd like for you to answer some of these questions that we have here. As a general question, there was a question about the PDF documents. We will certainly provide an overview of the session today, covering all of the software and hardware that was mentioned. And we can speak to anybody individually as well if you have questions. Let's see here. We are recording the session. And we are hoping, barring any unforeseen technological challenges, we will have this session posted at a location that you can watch at a later date. Lyle, this is a question for you. Is there any reason why anything that you demonstrated? The question was that they knew we were using CAD MEP, of course, layering on top of AutoCAD. But the question was, were you demonstrating with AutoCAD or AutoCAD MEP, and does that really make a difference?
I was using standard AutoCAD, but it doesn't matter. You can use AutoCAD MEP or just whatever's in your design suite, really, whatever is available.
Okay, very good. So anything you demonstrated would work with either one of those underlays, correct?
Correct.
All right. Next question here. Is Glue available for the Android? Mark, can you speak to that, please? I think you might be muted, Mark.
Yep, thank you. Not yet, but I'm sure that Autodesk has received that question many times. So at some point I expect it will be, but right now it's not.
Okay, so right now when you're using Glue, I believe there is some tools that are used on a PC. Are those in browser, or are those installed natively on a PC in a Microsoft Windows format?
Those will be actually both, and there is a shortcut that does get added to your computer, so there's a one-click access to the Glue project.
Okay.
So yeah.
So the field equipment uses iOS platform or iPads, and then back at the office there are some tools that you can use on your PC as well, correct?
Correct. That is correct.
Okay, very good. Let's talk, Mark, a number of questions came in, and I'm just going to summarize a lot of them by saying, help us understand the real functionality differences. It looks like a lot of the questions are asking about the difference between the Clash capabilities collision tolerances, those type things that are different in Glue and Navisworks. I know that I've heard many times said that they use the same Clash engine, but I've also heard that the Navisworks is more robust with respect to revision, history, and those other kind of things. Can you speak to that a little bit?
Yeah, and that's correct. Navisworks definitely is more robust as far as collision detection, but what majority of people use with Glue, or they're looking for clashes, it'll do that. You can set up certain tolerances with Navisworks, but a key difference between Glue and Navisworks when it comes to collision, people want to generate reports with Navisworks, and that's what you do. With Glue, you can't print out a report because what you do is once you discover the collision inside of Glue, and then you use Pinpoint to show you the objects inside your model to update, you update the model, you glue it up to the website again, you rerun the same Glue clash detection, and it will show the clashes that have been resolved. It'll show them as being resolved. If there's new clashes, you'll see new ones. But the idea is you don't want to generate a report. You just keep updating the model and reviewing the clash report on the Glue website.
Okay, very good. And I think you demonstrated what I think is one of the most powerful differences between the two is and it took me a little time to grasp this, but when it comes to the overall coordination flow of the models, the Glue is just much more superior because of the single-click button that pushes and updates the file to everybody at once. And so I think what's important about that, and you demonstrated it very well, is that as many of the people on the call know, is that when you fix one clash, you may create others. And so there's this process of weeding down the clashes towards the end and minimizing any kind of field coordination issues as much as possible. But I think the Glue is probably superior at that element. Is that accurate?
I agree. I think you summarized that very, very good. It's the Glue feature. I saw one question here. Some people think that maybe it's not as robust. It is extremely robust. You just can't compare it head-to-head with Navisworks because there are certain things Navis can do, but it is still a very robust feature inside of BIM 360 Glue. And some people find it easier, more intuitive to use than Navisworks is.
Okay, very good. Well, we've got time for just a couple more questions. I want to address this. We had a question come in asking about, and I'm not surprised by this question. So many of our customers that use the Academy P software have been pushing their points, their hanger mounting points out to total stations for years. And now we talked a little bit about Autodesk point layout. The question, I think, is basically says, in our workflow, are your point numbers from APL synchronized with the prefab hanger data? And I think they're really the same points. You can pull the same points off your hangers using Academy P as you would using APL. Is that correct?
I would have to test. Now, the point data that comes from APL, the points have some additional information, such as the XYZ coordinate, a description as well. As well as some other ways of sorting the points, because in a typical model you'll get thousands of points, and so APL offers ways to kind of filter and organize the points. So on the Academy P side, I think I'd have to do a little bit more testing working with Lyle just to make sure that the points from his program will work, or we can generate a report for the total station.
Okay.
Yeah, here, this is Lyle, and really to answer that, I believe the answer is yes. Between the two, because now in Academy P we can export it out as a text file, and so there's some things that we can do.
Okay.
If it's not a one-to-one comparison, there are some things that we should be able to do to make them the same, or as well use point layout throughout the whole thing.
Okay, very good. And what I'm kind of hearing you say, and I kind of understand this, the Autodesk point layout is more about a bidirectional workflow, being able to bring the data points back for QA/QC, and so there is extra information in the point. Each point has more information attached to it, which gives you these broader features of sorting and and existing position, new position, those kinds of things. And so I think it's really just a matter of improving what you can do with the data beyond the CAD MEP. But we know many of our customers use the CAD MEP points, and they're effective. But if you want to move to that next level, then the APL is the way to go.
Yep.
Okay, very good. We'll tender one last question here. Let me see here. Let's see. A quick one here. Does the glue have the pinpoint feature in AutoCAD?
Yes, it does.
Okay, good quick answer. Excellent. Are you going to go over the field verification and commissioning using laser scanners? What was the outline of the, that was in the outline of the webinar? So I know that the laser scanners have been used for doing concrete level mapping. Can you speak, and I assume that's what they're talking about. Can you speak a little bit to that? And maybe they're just talking about placement of items in the field using a laser scanner, not to be confused with going back and checking individual points with the robotic total station.
Yeah. When it comes to using the laser scanning, inside of APL there's two features in there to do a slab analysis and a point cloud analysis. So traditionally we talk about using that with concrete, and so we can test how flat the concrete is and see if maybe the forms have moved or bulged. So with APL we can do a slab analysis or point cloud analysis, and we compare that to something inside the model. The amount of information, if we're going to deal with MEP, I have not tried it, so I don't know how easy that would work on the MEP side. It's traditionally done on the concrete side.